Good afternoon, everyone. Thank you so much. This is the last session. I want you guys to give yourselves a round of applause. You made it. I hope you guys had a fantastic time. This has been a great conference. Just a final note, I do want to push the sprints one last time. As you may well know, this is not the last day of PyCon. There are development sprints happening tomorrow onwards. And this is the best time to work with the world's best Python programmers, the world's best minds in the, in this city. You have the advantage of working on high-profile projects like Mercurial and PyPy and Pyramid and all sorts of other projects, including getting help for your own projects. At the end of the lightning talks, which I highly encourage that you go to, you will be able to pitch for 20 seconds one of your projects that you want to have help with. Please go there. Pitch a project, like any kind of project that you've wanted to have advice on, even if it's a little hobby thing. Go and pitch it. Show up to the sprints. Or if you get really excited about someone else's project, please go and contribute. It's the best way to get started in open source. Now, it's my pleasure to introduce Carl Meyer, who, when he's not hacking on Python, plays a mean ultimate frisbee, and he's going to be talking about setting your code free, releasing and maintaining an open source Python library. Please, a big round of applause.
Thank you. I'm Carl Meyer. I work for Oddbird. We build web applications and do Python code consultation and review. So if you want to hire us, you can let me know. I'll be talking about releasing and maintaining your first open source Python library. The premise of this talk is that you have code. Writing that code is outside the scope of this particular talk. We presume that you have it already. We're presuming also that you want me to use your code, and the particular means is via pip install. There's other methods of getting your code to users, web application deployment, or creating GUI installers, or operating system packages. Those methods of getting code to users are also outside the scope of this talk. We'll be discussing pip install. And the other premise is that you want me to contribute to your code. And presumably you want to be able to accept my contributions without breaking your software or losing your sanity. So you look up some documentation on the internet about how to do this with a Python project. And you may find more than one source of information and documentation and more than one relevant project. And it might be a little confusing finding your way through and navigating the various advice and documentation. When you're doing something for the first time, too many choices can kill your motivation to finish it. So this talk, the idea is to present a set of rails for releasing and maintaining your first open source Python project. It's not the only way to do it. There are many choices that you could make. This is one set of choices that can work. So we'll be long on opinions here, short on choices. The idea is from 0 to awesome in 20 minutes. Some of the awesome that we'll have after our 20 minutes are over includes public HTML documentation with a responsive theme that automatically updates when you push to your repo, tests that automatically run every time you push to your repository, pip install working, and a project that's welcoming to new contributors. And if you've done this before, if you're already the owner of a Python open source project, hopefully you'll still pick up a new trick or two. The roadmap for this presentation includes talking about project structure, choosing a license, where to host your code, your documentation, testing and continuous integration, packaging your code so people can install it, and setting up a community around your project that's welcoming to new contributors. Here's a bare bones project structure for a hypothetical project. I've named the hypothetical project PyFly, which I was shocked to discover is not yet registered on the Python package index. So consider this the 0 day for that. We'll see who's the first to register it and build something under that name. We'll have a docs directory within our outer repository directory where our documentation will live. We'll have a top-level Python package containing all of your Python code. That's marked with at least a dunder init.py file and probably some other Python modules. We'll have a tests directory where our tests live, a license file, manifest.in we'll talk about a little later, a README, and a setup.py, which is what makes your package installable by other users. The first decision you have to make if you're going to release some code as open source is what license you'll release it under. Obligatory disclaimer, I'm not a lawyer. None of what's on this slide is legal advice. But your license is the conditions under which I may use your code. If you don't have a license, the default is all rights reserved. So the fact that you've pushed your code to GitHub does not mean I can use it. If it doesn't have an open source license, then you have not given me any conditions under which I'm allowed to use your code. If you aren't sure what license to use, I recommend starting with BSD or MIT license. These are less restrictive open source licenses. Essentially, all you ask from your users is that if they modify or redistribute your code, they preserve your name attached to it, so you keep your credit for writing the code, and they preserve the license under which you've released the code that you wrote. So if your interest is in having people use your software, almost anyone can use your software under those conditions. Other reasonable alternatives, if you know why you need them, include the GPL or LGPL, the Apache license, or the Mozilla Public license. The GPL in particular is a bit more restrictive. It requires anyone redistributing or modifying your code to release all of their contributions under the same license. If you're concerned about freeloaders, you may think about that. It will probably mean that some people choose not to use your software, so that's the trade-off. Don't use any other licenses besides these. The goal of the license is to clarify for someone else the terms under which they can use their software and reduce their concern that they'll be getting into legal trouble by using your software. If you use a less well-known license, you're simply giving potential users of your software a reason to question whether it's safe to use. You don't want someone considering using your code to feel like they have to go ask their legal department whether it's safe to do so. So you avoid that by using a well-known and common license, and you help to avoid license proliferation. Quick hat tip, most of the advice on this slide comes from a lightning talk that Jacob Kaplan-Moss gave at DjangoCon EU 2010. If you find my slides online later, this is a link to that lightning talk, and you can see that advice in a little more depth. So here's a sample of how we apply a license to our code. We simply put in the license.txt file, or in some cases, some people call the file copying, the text of the license you want to use. This is the 2-clause BSD license, one of the ones I recommended as a good choice. We got a lot of items to get through in this talk, so thankfully some of them are going to be very short and sweet, and this is one of them. You should host your code on GitHub because that's where the people are. Documentation is another one that's short and sweet. I like reading code. I read a lot of code. I will happily read your code to find a bug, to find out what I'm doing wrong, to fix a bug, or just to better understand what your library does. But if I have to read your code in order to even start using it, to figure out the very first step of what I need to call in what order to make it do a thing, then I'm probably going to decide that it's easier just to write it myself, or I'll use a competing library for the same purpose. Fortunately, how to write your docs and how to host them are also very easy choices these days. You should write your docs using Sphinx, which is the tool that Python's own docs are written in, and you should host your docs at Read the Docs. To get started with Sphinx, we'll pip install it, change into the docs directory, run the Sphinx Quick Start tool, which will just ask you a series of questions. For your first time, most likely the default answer to every one of those questions will serve just fine. Once you've answered all those questions, you'll have a number of files in your docs directory, and one of them will be index.rst. And you can just jump right into index.rst and start writing documentation. Sphinx docs are written in the restructured text format. If you haven't written restructured text before, it's very easy to get started with. We have underlined headers. We can have different layers of headers with different underlined characters. We can have inline formatting, bold. We can have code literals inline. And we can have code examples just introduced with a double colon. And this code example will automatically be syntax highlighted as Python code. Even if you write exactly this much documentation for your package, it's already miles ahead of a package without any documentation. I can look at this and I already understand to do the most basic thing with your package, this is what I need to do. And this this would take 5 minutes to write. So then we'll run make HTML to generate an HTML version of our documentation. And after we've done that, Sphinx gives us this, a nice table of contents based on our header structure. We see all our syntax highlighting there in our code example. So you just get HTML files. So then we want to host these publicly, and for that we'll use read the docs. So we go to readthedocs.org, give read the docs a few pieces of information, a name for our package, and the repository URL. And then we head over to GitHub and activate the read the docs webhook from the long list of GitHub webhooks, and then push to our project, and we'll have documentation built, hosted publicly at readthedocs.org using their theme, which is mobile responsive. You can build multiple versions of your docs. It'll automatically build one for various tags or branches in your code base and gives you a version switcher for people to choose which version they want to read. If your code is changing over time and you don't have automated tests for it, or else a QA staff, over time the likelihood of that code being broken approaches 1. Having tests is important for any code, but for open source code it can be especially important. Here's a problem that open source libraries often have is the dependency matrix problem. If we have 5 versions of Python that we want to support and 5 versions of a dependency, say Django in this case, if we're writing a project that depends on Django, now we have 25 different boxes here that represent environments that we ideally should be testing if we really mean to support all of these versions of all of these dependencies. If you aren't actually creating 25 virtual envs and running your tests under any one of those environments, then your claim to support all of those environments is purely theoretical, and over time it's almost certainly not true. Fortunately, there's a tool to help with this problem. The tox tool. With one command, tox will create a whole bunch of virtual envs, all the ones that you need for all the environments you need to test inside, and it will run your test in all of those environments. Here's an example of a very simple tox setup. You place your tox configuration in a tox.ini file in the root of your repository. You give it a list of the environments in which you want to run your tests. This is a very simple tox.ini. We're just running our tests under Python 2.7, Python 3.4, and under PyPy. Originally, I had only the first 2, but then Alex Gaynor looked over my shoulder and saw my slides and then tied me up and wouldn't let me go until I added PyPy. Then we also define the dependencies for testing our project. So in this case, we'll say we want to install PyTest, and then the commands that need to be run to test our project. In this case, we'll just run py.test. You can stick anything in here that you can run at a shell prompt, and Tox will decide whether your test passed or failed simply based on the return code. So you can use any kind of testing framework you can imagine with Tox. You can, of course, do much more complex things. Tox can handle the full matrix of dependencies and Python versions that we saw in the previous matrix. I'm showing a very simple example here. If you want to see how to do more complex things, you can check the documentation, or I'd be happy to show you some real-life examples after the talk. When we run Tox, it packages up our project. It creates a virtual env for Python 2.7 in this case. It installs our dependencies, installs our project into the virtual env, runs our tests. Here we see the output from PyTest running our tests, three tests passed. And then you'll see exactly the same output for Python 3.4 and again for PyPy. And then at the end, it informs us that our tests passed on all 3 environments and gives us a smiley face. So you have Tox set up. That's great. With one command, you can run tests and verify that you support all the environments you claim to. So you get a pull request from someone. So you open your terminal. You add the source of the pull request as a get remote. You fetch that branch, the source branch for the pull request. And then you run Tox. So it's still a lot nicer than having to run your test 25 times for that pull request, but there's still a bit of boilerplate work in there you have to do to review a pull request. Wouldn't it be nice if when you first looked at a pull request to your project, you already knew whether the test passed or failed? This used to be a hard thing to do to set up. Today, fortunately, it's easy thanks to a number of services. One I'll talk about today is travisci.org because it's the one I've used. Drone.io, I think, is another service that does similar things. There may be others. Travis CI will provide continuous integration for free for public GitHub projects. To use it, it's very easy. Go to travisci.org, log in with your GitHub account using OAuth. It will give you a list of all of your public GitHub repositories, and you simply click the on button for any of them that you want to run your tests on travisci.org. And it will automatically set up the webhook on GitHub for those projects. Second thing we have to do is tell Travis how to run our tests. We do this via travis.yaml file in our repository. It serves a similar purpose to the talks.ini. We tell Travis that it's a Python project. We want to run our tests under these 3 Python versions. We need these install commands run before the tests are run, and this is the script for running our tests, py.test. There are tools to automatically convert a talks.ini to a travis.yaml and vice versa. One is called panci. You can also, there's tricks you can use to make use of your talks environments within your travis.yaml. For my projects, I tend to just maintain them both in parallel. They don't change that often, and it's not hard to do. It's simpler. So once you've done that, you'll get something like this from Travis. Every time you push to your repository, it'll summarize whether the build passed or failed and show you each environment that you specified, whether that environment passed or failed. And every time someone sends a pull request to your GitHub repository, GitHub will even show you above the pull request. Travis will run your tests using that pull request code, and GitHub will tell you whether the test passed or failed. So the first moment you look at a pull request, you already know whether it broke the tests. So you also want someone to be able to pip install your thing. The key to that is the setup.py file. We'll just look at a sample setup.py and go through some of the key elements in it. In this setup.py, we're going to use setup tools, which is a third-party project. It's not part of the Python standard library. In practice, almost everyone has it. If you're concerned about people being able to pip install your code, pip relies on setup tools, so you can assume that your users will have setup tools already in that scenario. We have a readme.rst file, which we wrote some very basic documentation, maybe linking to our full documentation. And GitHub will display that on the front page of our project on GitHub. And the Python package index has a similar long description where you can have restructured text formatted description of your project. So it's nice to reuse the README we've already written as our long description on the package index. So we can do that in setup.py just by opening the README and assigning its contents to our long description. We call this setup function. When you execute setup.py, the setup function will magically do some things based on whatever command line arguments you gave. And we pass to setup.py a variety of metadata about our package. So the name of the package, the version, a short description, our long description, the author's name, the author's email, URL homepage for the project, the list of Python packages in the project. So in this case, we just have one top-level package, pyfly. Install requires is where we can specify dependencies on other packages. In this case, we'll say we depend on the 6 package, which is tools for supporting Python 2 and Python 3 in a single code base. And then lastly, trove classifiers. These allow you to provide extra metadata about your package, which automated tools can use to collect statistics on the package index or make decisions deduce things about your software. These are not used by pip, so specifying your Python version support here won't affect what pip will or won't install, but it can still be useful for knowing how many packages on the package index support Python 3, for instance, if you provide the versions you support here, and your license here also is just providing information to your users in a structured way. Another file we need for packaging is manifest.in. When your setup.py builds a source distribution of your package, it will include all of your Python code automatically, and if there's any non-Python files you want to include, we need to specify them in our manifest.in. So in this case, we'll include our authors file, a changelog, the license file, our manifest.in, our readme, and then we'll include all of our documentation. So anyone who downloads a source distribution from the package index also has access to the documentation in source form. Once we have those 2 files, we're going to prepare to release to the package index. Before we release, we'll tag our release in GitHub. We'll push our tags to GitHub. It doesn't happen by default. And then we'll create a source distribution. sdist stands for source distribution. It's just basically a tarball of your code and some associated files. You can create that with Python setup.py sdist. There's also a new wheel format, which I'd encourage you to look into. It's a binary format. So if your package has compiled extensions, using the wheel format will make it much easier for people to install. If it's a pure Python package and it's your first time, it'll probably be simpler just to stick with sdist. That's the most common format and still works very well for pure Python packages. Once you have your sdist, you can actually install it directly with pip. Setup.py will place the sdist inside the dist subdirectory, and pip can install directly from that tarball. And that way you can test and make sure that your packaging works correctly, that your package installs, and you can import it and use it before you actually upload it to the package index. Now, Python setup.py does have a command for uploading code, uploading your sdist to the package index. Unfortunately, it works over a non-encrypted connection, so it actually passes your package index credentials unencrypted. So rather than using that, we'll use a third-party package called Twine, which can securely upload your project to the package index. So we'll pip install Twine, and then we just say Twine upload and point it at our tarball, at our sdist, and it'll upload it to the package index. Before you can do this step, you need to have already gone to the Python package index webpage, created an account, and claimed your package name on the package index. And then you can use Twine upload to upload a version of your project. Once we've done that, we should be able to pip install PyFly, and our package will install from the package index. So the last item I'll talk about, or first, for more information about packaging, there's a lot more that could be covered. Packaging.python.org has documentation. There's an IRC channel, PyPA on Freenode, where there's people hanging out who will be glad to help you with your packaging problems. And there's the distutils.sig python.org mailing list. Last, we'll talk a little bit about building a community around your project. People join communities because they make their lives better. So building a community around your project is all about finding ways to make your users and contributors' lives better. A lot of that has to do with valuing their time. So we'll talk about some ways to value the time of your users and contributors. One way to value your users' time is to communicate clearly about changes to your software that will affect them. Semantic versioning is a technique to use your version numbers to communicate information to your users about changes in your software. The idea is that if you have a version number like x.y.z, you'll increment x anytime you make breaking changes to your API. So if someone knows that if they upgrade from version 1.0.0 to version 2.0.0, they're likely to need to update their code to use your software differently because you've made breaking changes. You increment y for feature changes that are backwards compatible. And you increment z for releases that include only bug fixes. semver.org has more information about semantic versioning. Another part of valuing your users' time, when someone sees that you've made backwards incompatible changes, the change log is where they can look to find out what those changes are and what kind of things they'll need to update in their code. So semantic versioning tells your users about the magnitude and the type of changes in a release, and the change log gives them details. Changelog is not just something you can generate automatically from your commit log. It should pull out user-interesting changes and summarize them in a user-friendly way. Here's an example of how I structure a changelog using restructured text. So a way that you can value your contributors' time and save yourself time is by having a contributing document. Here's some things that you might want to include in your contributing document. We'll call it contributing.rst in the root of our repository. You can include things like how to get set up for development, how a contributor can run the tests for your project, what they should include in a bug report or a pull request, what coding standards or test coverage standards or other requirements you have for contributing to your code base that they should know about in advance. And nice side effect, if you have a top-level file in your repo called contributing.something, GitHub will find it and automatically provide a link to it prominently on top of the new pull request or the new issue form. So contributors will be guided to your contributing guidelines before they contribute. So I'm all excited to fix a bug I found in your project. I download it, I follow your contributing guidelines, I get all set up for development, I install all the dependencies, I'm all excited to run the tests so that I can have a clean slate to work from and make sure I'm not breaking anything with my change. And 4 tests fail. And my motivation to contribute to your project is gone. So one very important thing you can do is keep your tests passing. Another way to value your contributors' time and contribution is to give quick feedback. When you get bug reports or pull requests, you may not have time to deal with them right away or think fully through the feature request or how to fix the bug, but you can very easily give a one-line response on the issue or pull request saying, I don't have time to look at this now, I really appreciate the contribution, I'll look at it next week or in a month or maybe in 3 years or whatever the truth is. But you can give immediate feedback for contributions. And when people pitch in, you can give them props. You can do that in the commit message, you can do that in your changelog, you can do that in an authors file that lists all your contributors, you can do that with tweets, all kinds of ways you can give people props and give them credit for their work, but that motivates people to contribute. Even beyond that, if you have helpful contributors who have submitted a couple good pull requests, you can be very quick to give them commit access. With distributed version control, commit access isn't as technically important as it used to be, but it's still a mark of confidence. It's still a social signal that you trust someone to handle your project correctly. And so giving commit access to someone will motivate greater involvement from them. And chances are someday you're going to be tired of maintaining this project. You're going to want to move on to other things. You're going to have other things demanding your time. So giving commit access to someone is preparing someone to possibly take over the project from you in the future when you're done with it. The very last thing, but definitely not least, anytime you get a bug or a pull request on your software, even if it's irritating or it's phrased in an aggressive way, or if someone hasn't done their homework and read the contributing document or whatever it might be, it still represents someone who took the time to take the initiative to make a contribution to your project because they wanted it to be better, because they cared about it. It represents someone who cares about your project, who took time and energy to try to make it better. And regardless of what other issues you may have with their contribution, you can always thank them for taking that time and energy. For every one person that you communicate with directly in a public way via an issue or a pull request on GitHub, or a mailing list or IRC or whatever, there may be 10 or 20 or 50 or 100 other people who will see that interaction either now or in the future, and based on what they see in that interaction may make a decision about whether it's worth their time to interact with you and contribute to your project. So there is nothing to be lost by being nice to everyone who contributes to your project. So, go forth and release code. I think we have about 4 minutes for questions.
4 minutes. Questions with the mic in the center, please.
Thank you very much for a nice summary of many good things you could do to your project. And a few comments. I don't know why Git people did it, but you don't want to tag only Git tag and then the tag. You want to use annotated or signed tags. Because if you use git describe command, which is really useful to define where you are in the actually history of development, those will not be used. So use those with -m, you can provide even a message which describes it right there in the command line.
Yes.
Then for licenses, I'm sorry I've missed that part, but I asked around. If you're using third-party code in your code, it would be great if you come up with a description of what code have you used, what is the copyright, what is the license. License itself without copyright doesn't matter. So it needs to be a bundle of copyright and the license. Also be careful about looking at the third-party modules which have more restrictive licenses. If you use GPL code and your project is MIT or BSD, effectively at runtime it's GPL. So those guys in the next room who compile their code, right, and deliver it, that will be already GPL code. You would need to provide your sources. Well, not in this booth, where it's important since we do it open source anyway already. And if you do semantic versioning, that's awesome. But if you want to verify somebody else's version, you could use dist utils loose version and strict version to do proper comparison, not like break into tuple and then compare it some other ways, because that might fail badly if you use development versions of other projects. Thank you again.
Great. Those are great additions. Thank you. I originally included -s in the git tag command, and you should definitely sign your git tags if you have a PGP setup. Also, if you have GPG setup, you should also use --sign or -s on your twine upload, and that will sign your sdist file on the package index. I removed those so that it would work for people who don't have GPG setup, but if you're going to be releasing software, it's probably worth your time to get a GPG key set up and make sure you're signing those things. So thank you very much. Yep.
Thank you. It was a great talk, a lot of information. How do you feel about using GitHub as a source of requesting people to help on your project, in the sense that you have an idea of where you want the project to be, and you have a certain level of skill, and you kind of got it to get started, but you need assistance? Do you see that as a bad way to get started, or?
Using GitHub to get contributors, how exactly?
In the sense that you're not at the level that you need. You need assistance in your project, but you have some sort of working code, like that's the boilerplate of it, in the sense that you would like other people to help contribute to your project.
It doesn't hurt to try. I mean, usually my experience is that you get contributors because you've built something useful that helps them, and then they need something else. They need to do something else, and so they're motivated to add to it. So if you put something up on GitHub that's more an idea than actual working code, I think in most cases that probably won't be that successful. But if it's something that a lot of people really want, I mean, it doesn't hurt.
Thanks.
Yep.
Hi, I was wondering if you have advice for maintaining those manifest.in files. Like, I've broken libraries that we use internally because I've made code changes and then forgot to update the manifest.in file to include like my new Python file or whatever. So are there tools or advice or anything for that?
There aren't tools that I've used to help maintain manifest.in. There may be some out there that I don't know of. But yeah, that is a problem. It's a good reason to test your sdisks before you upload them to the package index. Another thing I should probably mention is that one thing I didn't have time to include in the slides is what to do if you make a bad release, if you do upload a release to the package index that doesn't work. And the answer is you should not remove or change that release. Once it's up on the package index, you should consider it there for good. You just upload a new release with a bumped micro version number and move on. Yep. Yep.
Oh, I have one more question, last question. Thank you for the talk, and I know it's still a lot of steps, and it's at least it's a lot less messier and less complicated for now. But do you feel that, to what extent do you think that some of the steps can be automated in the future, perhaps, to make it much more easier for getting packages set up?
It's already a lot more automated than it was a few years ago. I mean, a few years ago, if I'd given this talk, we wouldn't have had read the docs, we wouldn't have had Travis CI, and so there's some very important steps here that would have been way harder a couple years ago. So yeah, I presume that I hope that things will continue to get easier, particularly on the packaging side of things. There's definitely movement in that area, so we'll see.
Thank you.
Thank you. Yeah, and I'll be in the hallway if anybody wants to talk more about things or argue about them.